First off, I just wanted to thank everybody for coming. Hopefully everybody was able to find parking okay. I know it's a little bit difficult in downtown Kitchener, so that's achievement number one you guys have already done. So welcome again. This is the Unique Applications of Computer Vision. This is hosted and presented by GDG and Applied Board, with special thanks to TD. So, first off, we just wanted to give a really big thank you to our sponsor, our sponsors and everybody that made this happen. So first off, GDG, or also known as the Google Developer Group, they're helping arrange a lot of different tech meets in Kitchener-Waterloo area, as well as a lot of other places. So you have them to thank for the pizza and the pop. Also, TD. Before working at Applied Board, which I guess you noticed from the swag, both Dexter and I, we worked at TD Lab, and we worked on some projects over there, and they've been very graciously willing to let us talk about some of the projects that normally are completely under wraps. We signed NDAs, but we are okay to talk about the stuff that's here today, which is great. So thank you again, TD. And lastly, Applied Board for allowing us to use their space. That may or may not have something to do with me working there, but I mean, once again, thank you to Applied Board.
Now, there's some repeat stuff here, like the TD Omos kind of took from me, but yeah, it was really cool that besides just Omos and I working on the project we're going to highlight today, there's actually, I swear half the people here worked on, no. There's actually 2 different terms of interns that are here that both worked on different versions of this, so it's really cool to have them here. So don't think as we go through this that Omos and I take all the credit for it. But now I work at Shopify doing mostly natural language processing and data science. The 2 products I work on are called Kit and Ping. They're basically startups that Shopify has acquired, and then they needed to add data teams. So that's what I do. Back to you, Omos.
Okay, back to me. So I have worked at a few different places. OneSet is a startup that I co-founded with some family. I've also worked at OpenText, again, TD. I currently work at Applied Board, and I've had my fair share of doing research work with Laurier for quite some time.
Cool, yeah, so let's get into this. So we thought it would be really cool to highlight something that was a lot deeper of a machine learning project that we did, all the steps of it, and really highlight the problems we faced, because I think a lot of the times when we see products go kind of into production, you don't realize the amount of work that goes into them, especially when it's a machine learning one, the amount of work that goes into it. Yeah, so our big motivation was we worked in TD Bank's innovation lab, so what we did was prototype every 3 to 4 weeks was the goal, try to have something new, sometimes be longer, shorter, but it always kind of started with a step of like a design sprint. So we would work with our designers, and if you know like a lot of developers, they might think their design skills are good, but they're like not that great if you let them have free reign on an app. But it's this kind of back and forth with developers having all these really cool ideas, but not being able to figure out what would actually be useful to like the consumer, but then designers having all of these great designs, but not having an idea either how to implement things or sometimes being limited and not knowing what was possible. So there was a lot of collaboration to kind of go through these design sprints and figure out what would be a valid prototype that we could work on. So we kind of started every design sprint with discussing ideas, and then we would start to like sketch them out and stuff to get an idea what the screens would look like. But we found the amount of time it would take to go from ideas like this, we would try to rule them out here, but you wouldn't always know how they would render. Then something that really looked great on paper would be like the ugliest app, or it would be a very inconvenient layout when you actually tried to put it together. But the amount of time that it took to go from just a hand-drawn thing to either, as a designer, something drawn in Sketch, or as a developer actually recreating a hand-drawn design, which is even harder when you don't know which components you're trying to do. So we kind of thought, what if we could automate this flow? So we still do the design bit because you're less limited in that. You can be a lot faster in kind of prototyping, but then what if we could kind of get it to render right away, just to speed up the prototyping phase, not to replace the whole app development process. So we basically came up with this idea called Sketch the App. So it was originally called, it had many names, Sketch the Sketch, Sketch the App, S2A. But we kind of had this idea, like, what if we could make kind of like a component library where we could just say, like, this is the shorthand for an image, this is what a button looks like. And then when we start to work with designers and developers and whoever else is in our design sprints, which sometimes it would be business analysts, if we just said, stick to like these components, which are native to the system, but then try to figure out what your app would kind of look like for whatever you were discussing. So then, let's see what's on the next slide. We basically started trying to break this apart into a problem. So how can we automate something like this? So here's actually I just found this hand-drawn thing on, Almost and I don't have access to the original training data anymore since we left TD, so I just had to make this up. But it's very similar to what we were trying to do. So I drew boxes on the first one here. So you can see a very simple app screen. Basically, when you start to break it up into all of these different components that you need to pull out and then kind of automate the creation of, you can keep getting more and more granular. For each of these like boxes, you could start to pull out the text and the icons and things like that. So it was kind of this rabbit hole where it was kind of how granular should we get? But we had this idea, like, what if we can just start with detecting the bounding boxes for where each of these components are and what the component is, and then we can kind of try to work to parse through that. So here's an actual image of a bell that almost meant it's the snake from somewhere, or not a bell, a screen. And then this is kind of the version 1 of what we built. So I'll get a little bit more detailed, but you can see basically the flow is that this was a really bad screen. Chris might have been the one to draw it, I'm not sure.
I have all the training data on my phone because I took photos.
We'll be sure to let TD know about that after that. So then we'll be sure to distribute that as well after this. So you can kind of see for a simple one that we were able to train this object detection model, and it actually flagged like this is a button, label, images, header, that little X up there, and then from that trying to render it as some sort of app screen right here. So that was version 1, but how did we actually build it? And that's where all the work actually comes in. So we played with some different object detection models. This is where Chris really comes in doing all the heavy lifting. But we were trying to see what were the kind of pre-trained networks out there that we could leverage. One of the biggest problems of our space was there wasn't data that we could just get for this. Like there was no Kaggle or anything. We had to kind of make our own data for this, which was just consist of hand drawings in all of those different boxes. So what we did was try to leverage what's called transfer learning. So this is taking a network that was trained on a different task and then fine-tuning it just to your specific task. And the idea is that the network has already learned to pull out things like different curves and contours, textures, things like that. So it takes a lot less data to fine-tune it, but get a really accurate network. So for that, not yet almost, for that we use something called YOLO, which is this architecture that stands for you only look once. And it's very specific because it only passes through the screen once to be really fast. Whereas other networks will keep on going back and forth trying to like figure out where the candidates are and then keep refining that. And then to build or implement this neural network and fine tune it, we use Keras, which is a higher level version of TensorFlow. If you're looking at getting into deep learning, I highly recommend it. For us in our space, it was really convenient for prototyping because it was a lot faster to just plug and play things, and especially if you're just like stealing code online and then trying to adapt it. So then we basically built this model after fine tuning this YOLO network. And then we needed some way to host it. So it was all in Python. We had already done our training and stuff. So then basically we had the idea, why don't we just make an API for it? Like this is the simplest thing. And then we can afterwards make some sort of app that'll interface with our API. So for that we used Flask, which made it really easy to bundle all of our code we had already used for pre-processing and like doing transformations to the image. But then just we could reuse all of that. We didn't have to worry about putting it in a different language. So we had made this REST API. So then on the app side, this is where Ivan over there comes in, part of the OG app side of this. Basically, we wanted to make an app that you would take the photo, it would send that image to our API, and then that API would return all of these, like a JSON formatted kind of like way of parsing through all the boxes and finding all the nested elements and iterating through. So then when the app gets it, it can render it as it goes through. But to do that, there was some weird stuff. It didn't work great. I'm not going to go into all the details because that was Ivan's work that he did. But yeah. So the limitations that basically we learned from version 1. It was really cool actually being able to take a photo of a hand-drawn mock-up. People loved it. But with that, we had very slow latency because we were trying to upload the full resolution image, keep it as high quality as possible. So the transfer of that took a while. Then just getting it to go through our network, which was over 600 megabytes, then putting it back took a while. It required a separate server, so we always had to manage some other service and keep an eye on it. React Native required extra packages for other components. So for a lot of those really nice material components like cards and things like that, React Native didn't actually support them for material components. So we then had to get all these extra packages just to render these native components. And the other limitation we had, I was meant to mention this before, is the actual collection of the training data. I forgot to say that we actually had all of our co-ops in this space just hand draw different mock-ups of screens for a week, and then we ended up just getting I don't know if it was 100 or what. It felt like a lot, because then we had to sit there and label them. So that was our other limitation, was having a very small data set to train on. So then, as the story goes on, I quit TD. And then version 2 came board.
So before Dexter left, he gave me I think a 4-hour crash course on deep learning. Didn't work. So I had to read a lot of different books, and I inherited the project. Me being an iOS developer, this was completely out of my comfort zone. So I thought, how the hell am I going to do something like this? And how am I going to continue this project? So I thought, let's go back to the limitations that he saw. So all 3 of them, well, at least 2 of them required some sort of server. So it was slow because of the server, and the fact that we even needed a server, it was extremely annoying. Always having to set up a server, make sure we're on the same Wi-Fi, make sure that we can actually connect if we're on some crazy restricted network, and actually be able to send information from client to server. Those were the first 2 things that we initially looked at, and to solve those, we thought, why don't we bring everything client-side? So bringing everything client-side is something actually pretty new in the realm of machine learning. There's some new frameworks out there, there's Curelet-Balan, which is released by Apple. It's an open source framework that you can actually train models, whether they be object detection, text, you can pretty much do everything. And the other one is TensorFlow Lite. We decided to go with Curelet-Balan actually. And so when we're looking through this, we thought, the initial model, it was made with YOLO, and YOLO has such a high level of performance. It does so well in everything that it's doing, and we thought, whatever is backing Curelet-Balan, we just hope that it's as good as YOLO. But one thing that was really nice was that it was powered by YOLO, specifically tiny YOLO, actually. So Curelet-Balan is their object detection model is based off of tiny YOLO, which is more so, I guess you could say, a compressed version of YOLO. It's not as good, but it can run very, very fast at very high frame rates. So if you can look over here, I know there's a lot of them here, but you'll just have to kind of look at tiny YOLO is on the bottom, it's also on the top. But you can see, although its scores, the MAP scores are quite low in comparison to others, the frame rate at which it actually runs is very, very fast. So it can actually process 60 FPS for a lot of different, it can process video at more than 60 FPS.
244.
So, yeah, 244, so if everybody cares. But it doesn't matter because we can only see 30, right? He likes that joke a lot. You can go to the next slide. So let's go through the different things. When we implemented everything client-side, we ended up using Curelet-Balan with YOLO v2, and we can say thanks to Jacob, who is from our second TD cohort, who helped in the implementation of that. So let's go over what version 1.0 was able to achieve. First off, there was a server required. Second, internet required as well. Third, the model was 600 megabytes, which is not too big when you think of server. You could host whatever you want on the server. But one thing that was a really big pain point was this next one. Each request took sometimes almost up to 17 seconds. So that was a really, really big issue. And it touches on what Dexter was saying before. We were sending full resolution images up to the server, and we needed a better way to do this. So then along came version 2.0. There was no server required, so you could do this completely offline. Completely offline. The model actually went down to 60 megabytes when trained with Tiny YOLO, and the execution time was less than 1.5 seconds. So we had insanely large performance increases. The only thing we sacrificed here was about 2 to 3% on the accuracy on our model. But you know what? Sacrifices need to be made for the greater good.
I ruined your meme, I flashed.
Oh, did you? Okay. So although we had great performance increases, there were still some bugs that came around. I like these memes, they're really funny.
Scary.
So if you guys look at this image that Dexter showed before, there's something that you could probably identify where that's what's drawn, but this is what we see. And with the black background, you can really understand one of the issues that comes up is with this TD logo, how it's not actually being bound to the edges, where that's actually what we want to do. One other thing that's also a bug that we found is the buttons. Although the person is drawing them, they would normally want to draw these buttons and they want them centered and equally spaced and in equal size as well. That was something that no human can probably draw this right off the top of their head. It's not something that we can rely on. So this was something that we needed to fix. We needed to automatically balance the widths, the heights. We needed to do all of this manually. Go ahead. So for the TD issue, this was not too bad. It was just understanding when you have a flex value of greater than 98%, it probably needs to snap to the edges. So that was a really easy fix for us to do. But the other one was really interesting. What we did was we actually broke everything up into rows and columns. So this space, button, space, button, space, it was actually defined as a specific row with a specific height. What we ended up doing is we took these classifications and we labeled them. So we saw that one was A is a space, B is a button, A is a space, B is a button, A is a space. What we noticed was that this was a palindrome, or this was a symmetric row. By understanding this, we were able to take each one of the classifications and with a threshold, understand that if these are within maybe 5–10% of the width of each other, they probably want to be balanced. And so that was one of the interesting little solutions that we had for this. So we did 2 of the issues. There's still one more with the components. So we go ahead, next slide. So still, if we ever wanted to add another component, obviously here we have user input, icon, headers, image, button, but if we wanted to add anything more, so say Apple introduced a new UI element, for example, like a rating slider or something new, we would have to go back to our training data, we'd have to draw more images, we'd have to retrain the model, we'd have to go through this entire pipeline over and over every single time new things were implemented. So we thought, we need to do this a better way. We won't want to just be limited by the training data that we have. So this is an issue that comes up a lot in computer science where everybody overcomplicates things. So instead of just using GitHub, sometimes people use Google Drive to store their code. Some people, I hope they don't take a picture of their code. And some people, dare I say, read your code aloud and put it on Amazon as an audiobook. I would hope nobody does this, but this is obviously keeping to the extremes. But my point here is keeping it simple. Sometimes, yeah, you know what sometimes the resources given to us are more than what we need to actually solve these problems. So Apple actually provides something called Vision Kit, which has rectangle detection, face detection, barcode detection, text detection. It has a lot of different things already built in. So we thought, why don't we try to utilize that and try to solve the exact same problem? So we tried to use box detection. And one really interesting thing about box detection was that there was no training needed. If we were just drawing boxes, all we needed to do was use the box detection to understand, hey, that's a box. So that should probably be a UI element. Another thing was that every single UI element could be supported without training. I forgot to include that. There should be without training here. And that was just because if you had a box, all you had to do was support, it could be a slider, it could be this, it could be this. You could choose from a drop-down later to select whatever you wanted. And the last thing that was really, really interesting as well was you could actually save preset templates. So if you wanted to share different things, a different template of boxes with somebody else, all you had to do was share boxes with somebody. It wasn't something very complicated. So if we were to add some images to this, this is what, say, the box detection algorithm would see. And as long as somebody would be able to click on them and label them, so you click on the one box and say, I want that to be a logo or an image, I want that one to be a button, I want this one to be a button, and then after, start adding in colors or text, background images, corner radius adjustments, you could actually fully make a nice UI design. Obviously, yes, this is extreme, but it's still possible. given the boxes that are shown here, it's the exact same layout for the exact same elements. And so one last thing that we wanted to mention as well is that we have been hard pressing TD Lab to open up a lot of their different things. So we're looking to actually have TD Lab maybe share this with the general public. So we actually have Frank from TD over here, sent by his overlords, the executives at TD, who were trying to peer pressure into opening this up for the public. So if anybody would like to vouch for having this open sourced or shared with the public, please feel free to talk with either Frank back here or Dan over here as well. These guys are both people that we worked with. So please let them know. And if you guys are interested in trying this out, because the code is all open source, or even contributing, feel free to keep in touch with them or get in touch with them.
So I'd also like, this is completely up to the past students on this, but I would love to have the three of you come up and each highlight what some of the biggest obstacles you faced, because Omas and I were very much the overlords of this project, and we didn't have to do as much of the grunt work that you guys had to do. So if you're comfortable, feel free to come up. No advanced preparation. I thought if it really bothered them, it still will kind of burn. They'll remember it. So I'm trying to think, should we start it like time-wise throughout it, like a little...
Yeah, sure.
So Chris, this is you. What is the most annoying thing? You can just rant about them if you want.
Oh, finally, great. So I guess we had the idea of doing this project, but it really was starting from nowhere. So I think the first sort of challenge was figuring out a syntax for what all the different components are going to be, and sort of looking at our design team what their existing sort of sketches look like, so that we could kind of have a vocabulary of design elements that they were familiar with, but also could be easily sort of differentiated by object detection algorithm. So, I mean, that was sort of the first thing. The whole drawing all the strings and everything, it was just tedious. It wasn't really hard. It just kind of sucked your soul for a week or so. But once we got all the training data, the model, that actually wasn't too hard. We got pretty good accuracy using transfer learning. But the hardest part for sure was once we had sort of our image and it had different bounding boxes on the different UI elements, how do you sort of parse that into a JSON that actually represents an app screen? So there was a lot of sort of I feel bad for passing off my code to the next term, because it was super horrible in every way. But essentially having to come up with an algorithm that could sort of parse from the top left corner to the bottom right corner, find different elements that were horizontally and vertically aligned. We had cards, so we had to do sort of recursion for things that are inside other things, and then do horizontal and vertical alignment within those. So kind of getting that whole algorithm to work in a way that actually ended up working when we passed it off to the React team. That was probably the hardest part, but yeah, it was cool that it worked. So I'll pass off to Ivan, who worked on the developing of the V1.
Sorry, Jacob, your version 2, you gotta wait.
So, as they said previously, one of the hardest parts was making sure the server and the app were on the same Wi-Fi, because they were on the same Wi-Fi. But for the actual development part, we really ran into the issue of cards, because cards could be in cards, and there could be a ton of elements in them. And then we just weren't sure of how to display this all in a nice, friendly JSON format. So that was the largest issue we had with just cards, and then we also ran into the issue of just React Native in general. We spent a day trying to install it. We were realizing that we were using the wrong version of Node, which, yeah, that was a big mistake. And then once we got past that, the first project was built using Android, because the lab just had Pixel phones available. And every time we wanted a component, we would have to find a new library. And every time the library didn't have another component, we'd find another library. And then we would add another library in, just because it didn't look good on the other library. And then we'd find libraries that conflicted with other libraries. So that became a huge mess. All right, I'll just pass it off to version 2 after.
Yeah, so a couple of things stood out to me as kind of bigger obstacles. So when we moved to, when we trained the data with Curelet, we were getting like precision rates of like 40% originally. That's like with image sets of like 100, 120 images. So figuring out how to increase our precision rate, we ended up like augmenting all the images in like maybe like a few different ways, so that like increase the image set from maybe like 120 images to like 600 images, and then we were able to get precision rate like in the 80%. And then another thing was the creating like the element inspector. So once you've actually taken the picture and rendered the app, like actually customizing all the elements, it was kind of difficult to think about like the actual inspector, how it has to be dynamic, because some of the things you're editing, you can change like font colors for some things, but not for images. Everything has a corner radius, for example. So based on the element, each thing has different properties you have to change. So the element inspector looks different based on the things, but some have overlapping functionalities, etc. And then the last thing was, yeah, like the algorithms to kind of like line up all like the objects, etc. Because yeah, just like the idea behind that was relatively simple, but the implementation was pretty difficult, I'd say. Yeah, thanks.
Yeah, I'll also add that I feel that squiggle detection was always very low compared to the others. We always said like you can just squiggle to like do text, but a squiggle is very different every person that draws it, and it's not always consistent. Like,
and I think like all the squiggles I did, I like started at the bottom and went like that way, but if you started at the top, then it like would not detect it. So they're just very like idiosyncratic things that I didn't think about when designing sort of the syntax.
yeah, is there anything you want to add, Omos, to this? What was your biggest annoyance of this?
There was so many different things. I think the biggest issue actually for me was I worked with one of our other co-ops, Sophie, for the balancing and trying to make it so that we could actually snap things equally and make buttons be equal and remove white space. There's a lot of thought that went behind that, and even the solutions that we had, it didn't even scratch the surface in terms of how many bugs there actually were. But we did manage to squash quite a bit of them with some of our random algorithms that we built. But I think that was the worst part for me.
Yeah, and I think I'll add to that. We also I feel weren't very organized when we started. This started as like a 2-week exploration, and we didn't have any idea it would last over 8 months, that the TD would continue to work on it. So in those first few weeks, everything we did was on our computer or in Google Colab, or it was very messy, like just notebook files, and just like if we needed to distribute a model, you just sent it over Slack or emailed it. Something like that. Same with the training data that we had labeled, we just kind of like spread it around like that. But then as a project like this gets messier and grows and you bring more interns on and it just continues to suddenly become even bigger, you start to realize where a lot of the decisions we could have made earlier, even to figure out like what the best version of the model was and stuff, other than just putting it in the name of the model. But then you can only do like best, bester, and bestest for so long until you run out of things to add. But just figuring out how to better organize the training data, the whole pipeline, and just what you did that didn't work. Because I think there's always a lot of lessons learned in this. Did I miss anything else, Chris?
No.
Yeah, awesome. So yeah, I think, do we have any other slides here? Yeah, so that's the end of this. But yeah, thank you very much, everyone. We do want to leave this for a lot of questions and stuff. Yeah.
So after initial React Native problems, did you find any issue later on, or with using React Native?
So we just abandoned React Native actually, and we went fully native on iOS. Then we stopped running into all the issues with components. I think that's about pretty
That was
accurate.
version 2. I don't think we highlighted enough that our solution to React Native was just to get rid of it.
Yeah, that was also part of it.
Yeah.
Did you guys actually generate the code for the app, or was it like a guideline for the developers to follow?
Very much a guideline. We never thought that we could like recreate like a thing, and we thought we could export maybe boilerplate code, but it wasn't meant to be functional, right? Let anyone else add anything?
I think we did have like in the V1 at least, we had a function that you could take a photo of a screen and then actually click on a button, or take a photo of several screens and then have buttons that could map like hit this button, go to this screen. So there was sort of a very limited like sort of navigation component that we added into it. I don't know if that continued in V2, but it was more sort of a proof of concept for seeing what it would look like if it was a very early app prototype.
Just an add-on to it. So you just mentioned you went totally native on iOS, right? So then you would have to maintain 2 or 3 code bases for Android,
Yeah.
Xamarin, or whatever. Did you think about using Flutter, for example?
Actually, Flutter was, I think, announced around the time that we were mid-working on this project. So I think the same term, some of our employees ended up working with Flutter, but it was I think it was in the middle of when we were building this project that Flutter was really getting some traction, so we never ended up doing that. As far as maintaining multiple code bases, we just never touched the React Native code base again. So it was really just the iOS one going forward, just because there were so many issues with, I guess, npm install. But yeah.
And then adding to that too, I like, even in my current role right now at Shopify, we've explored deploying like machine learning models on mobile handsets, but more like for iOS and Android. And the support with CoreML and like Turing Create on iOS there's like, it cannot be matched on the Android side. Like all the stuff I've done with Android, it's still very much in like alpha version and stuff. Like it's really hard to actually make custom models and do the inference on a phone. If we had been managing a server, it would have been really easy for it, but because it was so easy for them to then bundle it with Turing Create and then put it just right into a Swift code base, it just made it a lot easier for them to adopt it. So I don't even know, like, if you built an Android code base from this, what would be usable from the model from the iOS? You'd almost start fresh and then have a completely different thing. So it's definitely not a seamless thing, and I think eventually this is what TF Lite coming from or like the newer version of it is supposed to fix, is that you can deploy the same model to both versions of like software. But right now it's so far out there, and even with React Native, if we had been trying to do this client side in React Native, it would have even been more of a nightmare, because we're already then trying to like jam it into like JavaScript, but then trying to access the system components. And then you actually have to access for like Turing Create and then, or CoreML, you use the iPhone GPU. So then to do like you start to realize what a mess it is to try and deploy these things, but then you start to look at the trade-offs. Like it went from 17 seconds to like 1.5 because you're not sending this image anywhere. And then it also makes it so it can be open sourced a lot easier, right? Like if you wanted to try this at your house, you don't have to spin up a server now. You just put it on your phone and then you can run it. But if you have to set up your own server, be on the same network, or if you want to use it anywhere, you have to deploy that server somewhere. It just starts to become this really big, it was a cute idea that then suddenly snowballed into something that was very hard to maintain. Yeah. For a nice jaded response, I guess.
Thank you.
Cool. Yeah. Any other? Oh yeah.
So you initially started with Python.
Yeah.
What made you not stick to Python?
So Python was more for just training the machine learning model. Most of the like libraries for machine learning, specifically like Keras and TensorFlow, are like mostly written to interface with Python. So we trained the model in Python, but then we first built the Flask service in Python just so we could reuse all of our stuff. We didn't necessarily abandon Python. Like in version 2, they started using this Turing Create tool that was from Apple that just allowed them to not need Python, and then train a new model that was already made to run locally. So we were using Python just to train a model and build the service in version 1, if that kind of makes sense.
I think
It doesn't really make sense. Why would you use anything other than Python when you develop the core of your API using Python? You could have continued using Python. Why did you go to JavaScript in the first place?
So that was only for the client side. Like Python was still there for the server side.
So why not for the client side use Python as well?
I don't think we can.
You can't make
I don't
mobile
think
apps in Python.
I don't think you can make mobile apps in Python.
You can convert it to PyC, and it's like basically the same native application that you're using with Java or JavaScript. You can do it with Python.
I've never heard of that.
I think the bigger problem is that for doing the inference of some of the models still, you can't like you need to access specific native components, like the GPU specifically. And even for doing that, you can't just in your vanilla code do it. You have to use something like TF Lite and their library interfaces with that on like an Android handset. And then for iOS, you need CoreML to actually interface with the GPU resources on a phone. So if you use something like that, same with like React Native, it doesn't have access directly to the GPU. So you still have to have some sort of compatibility layer in there. So for us, it seemed at the time faster to build a service and then build the React native app, especially because we had the other thing is we had mobile developers that were looking for their next project, and that was the resource we were given, not great Python devs and stuff. So part of it was also just the timing of it. But I think that a lot of this stuff, like even React Native, we thought in theory this would be really easy. We also, I think when we started React Native, we thought that we would be able to do some sort of predictions, like eventually if we shipped a model and put in an app and it would be on both platforms available. And then once you start to build your app and then you start to look into that, you realize, hey, like there's actually not a very easy way, especially for a heavy model. And that was our other problem, is it was over 600 megabytes. So there's no way we could bundle that. And then we needed to start looking at reducing the model, but without doing that, still just trying to figure out, can we even deploy this to like a phone without it being buggy? And then the 600 megabyte model, we basically, if we had done like a React Native wrapper, say we had managed to make it, the model itself would barely have fit in the memory of a phone. So even to do that iteration and stuff. So I think it was just a big learning experience as well. And I think now, like I would say it's very difficult still to deploy on Android machine learning model onto like the handset. But for iOS, if you're using what they have built and you're not trying to take something from other libraries, you use specifically what they have. And they actually do have a library to convert Keras models and scikit-learn models and XGBoost now. So you can actually train in Python and then just convert it directly. It seems iOS is really far ahead, which sucks for me because I love Android handsets. Yeah. If that kind of answers that question.
I have another question. So what kind of testing libraries did you use?
So you can see we're all laughing. So part of corporate innovation is you don't do a lot of testing. So other than the machine learning was easy to test because we just had like a test set we removed from it. So we would evaluate how well that model would perform. Yeah. But just having limited resources and every time we worked on it, it was a 2-week project. Then it got extended by a week and another week. So every time it was like, well, with most of our projects, it's like, hey, let's add testing. Instead, it's like, hey, let's build a new project now and something completely vanilla. So this, again, is not meant for what a production engineering environment was. This was very much a prototyping, more R&D research area and seeing what we could build. So I wish I had a better answer to that question. Yeah.
I didn't hear one of the other questions. I believe it was about what goes behind the buttons and so on. You guys are just converting the pictures into a set of GUI elements, right? Have you thought about how you get your users to draw in the mechanics that go behind the buttons?
Feel free.
Yeah, so I guess we had, I think I talked to it earlier, but we had very preliminary sort of navigation between different, like you click on a button, you can go to a different page. But in terms of sort of like if you have a drop-down menu, how do you implement those sort of elements? I think when I was originally kind of coming up with the syntax, we wanted to kind of keep it constrained in scope, just because you can very easily expand the scope, and there's so many different permutations. And we're originally looking at iOS and Android because we're using React Native, so we're trying to think of some elements are only actually available on one platform, not the other. So then how do you support that in terms of the interactive functions? So I think like even in the future, it would be interesting if this did get open source and we could expand on it and try to think of ways that maybe you take a photo of one thing and then there's another hand drawing where you have some sort of like navigation or some other hand-drawn element that can speak to more of the functionality of components. It would be really cool to be able to have not just an app that had a good GUI, but something that was functional, that you could totally give to a developer or a designer and say, draw it in this specific way, and it'll actually have functionality. And I think this is a really sort of open problem, which would be really cool if anyone in the room wanted to contribute to.
did you actually give your app to a designer and see if they stayed within the parameters of the project? Or?
So we did have a designer on our team, and she helped us with sort of the initial development of everything. I don't know if we really ever used it as sort of the starting point of projects themselves, but there was definitely a learning curve to, if someone drew an element in one way, you had to draw it in a certain way in order to actually have it work. And so as much as we had sort of it working as a proof of concept, if we were able to scrape data from the internet of all different hand-drawn sorts of permutations of how do you draw a stock image, how do you draw a slider, it'd be really interesting to see if you could detect sort of an individual's way of drawing component A or B. So I think we didn't really hand it off to our designers, but they were sort of a part of the design process of the app from the start.
And also, like, this is where we really wanted to make sure that the app we were making used native components for the platform, so like material design, because this is what, if they were using like Sketch to actually like do a mock-up, they would use valid components, they wouldn't make their own. And then this is where we had the problem with React Native, where like a lot of the components weren't actually native, despite native in its name, not native to it. So we would pull them in, but then when you show it to a designer and you say like, hey, I have a card, like, does this look good? And it's like, no, this isn't like actually valid, like a valid material design card. And it's like, there goes that library, let's just add another one. And then the amount of time it takes to then get those components put in there and get them so they're compatible with the rest of our code base became very difficult. And that's why it was kind of weird that we were using, instead of native like Android, which would have had all these components built in, we're using React Native, then trying to get these components to simulate a native Android app. So how's that?
So based on your experience doing this project for now, what is it that you would say you learned from this that if you're going to do a similar project in the future, you're going to be doing this?
It's a very good question. I think we can all answer that too. Do you want to start on one?
I'll start. I think we only spent what I touched on with box detection. I think it was one of our co-ops who just wanted to try it out to see how well it would work. It ended up working better than anything that we've done. So one of the biggest things for me would just be, don't find the flashiest, coolest solution. Just look for the most simple building blocks that you can find, because those are the ones that are going to be stable. They'll lay a proper foundation. Whereas if you resort to computer vision, sometimes your accuracy is going to be, 86%. I guess that's bad in computer vision. But we were sitting at around 86% on an average, I think, right? Ish? Yeah, whatever. But in terms of box detection, we were at 100%. Every single time there was a box drawn, we were able to pick it up. And if we're able to pick it up, we're able to build a UI from it. So for me, it was a great learning experience when it comes to seeing what the capabilities of machine learning are in computer vision, and not only that, but to recreate and what Keras can do with YOLO V2 and whatnot. But at the end of the day, when you go with these flashy systems, a large portion of error also opens up with it. So you need to make sure that the solution that you're trying to fix really needs that technology, and you don't want to force technology on a solution.
Yeah, like echoing that, I think that doing a lot more research initially and looking at like, say we one day build this model in Keras and we do want to deploy it client side, are we able to do that? Like, and look at like a lot of different scenarios and have a better idea, like, because we couldn't tell where the project was going to go, but if we had better mapped out like the different paths it could have taken, and then I think that could have really informed us a lot earlier about bigger decisions to make. So something like this, that like, it wouldn't have taken 8 months to do 2 versions, it could have been done faster. Yeah, that's probably my biggest takeaway, is just being better informed about things. And even like, it was hard for us at where we were in TV, because we were kind of like an outsider to the bank, so we didn't work with a lot of other data science and machine learning teams. By saying like, now that I'm at Shopify, I really enjoy that there's data scientists on other teams that I can consult with just about ideas and stuff. So I think trying to do a little bit more consulting and discussion around these things and plan it out ahead of time. Like it's very fun to be scrappy and just go into a notebook and start, but then you really pay for it, I think, eventually.
Yeah, picking up on that. So after I finished my term at TD, I actually started a master's at UW. So I'm doing computer vision research in the engineering department, systems engineering. So sort of taking the experience of this, the environment was almost very akin to like a R&D lab, almost more sort of academic in a way that you're learning things, you're implementing them, versus writing production code. But this was sort of the one project where the code that I was writing wasn't just staying with me, and it was, you know, what I wrote would be passed on to other teams. So I think two things there are, one, like model versioning is huge, and that's something that I'm trying to, I'm trying to implement in my own research now. So whether it's, you know, using tools like TensorBoard are really great for visualizing, you know, your model training over time, or I don't really even have the best solutions right now for other than, you know, using model checkpoints during training, so you can sort of have either in your file name or different directories a very sort of organized way of having different versions of every different parameter, what the hyperparameters were. Because at the start it was just, you know, we're going to do this for 2 weeks, so let's like train a couple models, keep the best ones, and oh no, actually the one from like 2 days ago was the best, so then do we still have that, or was it overwritten? So like when you're doing that, like in a very scrappy environment, like it's kind of okay, it's not the best, but now that I'm doing more research and I want to make sure that every experiment I'm doing I can report, that's sort of the biggest thing there. And then, I mean, as well, just code sort of quality, and trying to always, when you're writing something, think that someone else is going to use it later on down the road. That's like something that I didn't really have an experience with before this project, and I think it was a good learning experience for what I'm doing now.
On this project, we probably should have done a bit more research, because we were short on time, on the differences between, for example, material design and iOS, because that gave us a lot of issues when trying to convert the JSON we're given. And a large issue with our libraries was that we just had to keep adding more and more to deal with the differences between the two platforms. So everyone else has said they wish they had more time to design it. I say the same thing. So that's mostly it.
Yes, just like to tag on to what Amas said. When that other project came out with like the just using drawn rectangles and being able to associate user interface elements with that would have definitely been cool to explore. Then I guess it's like becomes less of a data science problem and more of like a user experience problem. But yeah, that definitely would have been a cool project to look into as well.
Do we have? I think we had one over there before. Yeah.
Excuse me, what was the question?
So the question was, what kind of tweaks did we perform to the tiny YOLO model to kind of fine tune it for our data set? If I captured that properly, cool. So I'll let Chris take this.
Sure. So basically, like, we kind of took YOLO as it stands. I think the default, I'm not sure actually how many categories, how many classes it predicts, but basically we, didn't change any of the architecture really, because, we were looking at, there's faster RCNN, there's sort of the two-stage models, which they do a certain, Dexter talked about it earlier, but they do one pass where they do region proposals to say, this is potentially an object, this is potentially an object, and then does a second pass where it actually classifies the objects. Those tend to have a little bit higher accuracy, but for our purpose, like, the elements are relatively simple, so we thought, okay, we want to optimize for speed. So then we looked at the literature. There's like SSD, which is single shot detector, there's YOLO, and we just found that YOLO, the code, the guy who maintains it, he has a really great resource for, and also he has if you've ever seen his resume and his papers that he writes, he just has jokes in his academic papers. It's pretty funny. But so basically we just said we don't want to reinvent the wheel. We want to take what YOLO has and then just change, I guess, the one change we would make was whatever the last sort of number of classes that we're predicting, we would predict the number of classes that we have in our vocabulary, and then I think we trained it end to end, so we didn't even freeze any layers, which we could have freeze some because lower levels are probably very common between all different object types, but the training wasn't that long because our data set was quite small to begin with. So yeah, that was basically, we just kind of kept it normal and got some pretty good results.
Any reason why didn't use TensorFlow Lite?
So that's what I don't think I went as deep as I should have earlier. So the problem with when we're doing this project is TensorFlow Lite was like in very much alpha mode and like was just like starting to work, and it only supported custom or certain layers and stuff. So if we use something like Tiny YOLO, it wouldn't have supported all the types of layers out of the box. Even in current day today, it's still very much not production ready, and there's still a lot of things that need to be done to get your model ready. There's still not all the layers that are supported. TensorFlow 2.0, when it's actually released, is supposed to fix a lot of that, but
yeah. I think one of the biggest things as well, to recreate, you can, as long as you have a labeled data set, you can git clone the repository, start training in 20 seconds. It's really, really easy to just jump in there. And with it being in a pretty stable state in comparison to TensorFlow Lite, we just decided to do that one. And I think we wanted to build an iOS app too, so I think that kind of also added to it.
And this like pains me because I love the idea of like building models from scratch. I very much view it as like an art. It takes a lot of like work and stuff. So then using something like to recreate just crushes me a little bit, that you just give it your data and it tries to figure things out like on its own and kind of automate it for you. So basically a developer can do it without machine learning experience.
It's not necessary anymore.
But it really was, I think, for deploying to mobile, just the fact that it's made it so easy. It's been hard for me to kind of swallow that, but it's really great that it is easy for iOS to deploy these things. But I do look forward to when TensorFlow Lite comes out, because you can do a lot more custom stuff with that you can't do in Create. Yeah.
Do you still intend to evolve the project at this stage, or?
So if it gets opened up, we haven't been able to touch the code base basically since we've all left TD and stuff. So I think if it gets into an open state, it's something that we've, like on the side, we said it would be so cool to rebuild that from scratch. Like there's so many things we learned. I don't know if anyone wants to add anything to that. But I think all of us are eager to like look at it when it comes out and actually try to do all these things, especially in our new roles. We've all learned, I think, a lot.
Or do you want to start a new project?
We could just let it die is the other, yeah.
No, like
But,
open source, version 3. You know?
oh, version 3.
Oh, V3.
I think, yeah, let's just keep hacking out things until it works. When TensorFlow Lite comes out for real, maybe that will be it, version 3. Maybe. Yeah.
Did you document
Okay,
somewhere all this story, or you have it in GitHub? You have also documentation, still what you told us here, steps and.
So the documentation that was packaged with it before we left, it was pretty detailed, and
Unless they hacked it apart.
No, it's still good. I think I got a glimpse of it. Dan was nice enough to send me a copy, but it's very well documented. So even if you don't have any experience with machine learning prior to cloning the repository, you can immediately just pick it up. We have the environments all set there using Anaconda. Literally step by step what line you have to put into the terminal, it's all there. And it's very detailed as well in terms of the algorithms, what they do, what other algorithms that we use, like the Huffline transform or the canny edge detection. Every single thing that we did, it's all documented very well.
How easy would you say the code right now is if you want to convert it into a bunch of microservices and separate concepts?
A bunch of different microservices?
Yeah.
Well,
like you are doing 3 different domains of the process here. One is recognition. One is pre-processing into a set of recognized elements, and then the other is curating those into the UI. So these 3 could be completely separated, in theory,
yeah.
and become multiple different solutions, and then you can separate each element into small microservices.
Yeah, so sorry, I didn't mean to cut you off, but one interesting thing that we actually brought up to a lot of the different teams in TD was The one thing that we actually missed out on when we moved everything client-side is the fact that the microservice architecture wouldn't be possible since everything is happening now client-side. One really good thing about having a server and a client would be we can take, or the way that the model worked was you could take a generic image, and the way that it would export this JSON was very similar to the way that Flexbox works. So theoretically, whatever client was taking the response, whether it be something that creates spreadsheets or Android apps, websites, anything would be able to actually process it. So it was very able to be used in a multi-purpose fashion in that sense. But we were more so curious about just performance at that point. And that's why we kind of strayed away from breaking it up into something that multiple different platforms could use.
You know how like Microsoft has moved their .NET framework into a microservice structure, where they have like tiny files that each of them does exactly one specific task. So I'm just asking, like, whether the code right now, how easy would it be to then convert it into that kind of structure, so you can.
Yeah, version 1 would definitely be the better candidate for that, just because it is separated.
And it would be pretty, like, I think a lot of the pre-processing and the image processing itself, like the inference, those things can be split up really easily for the first version.
Yeah, it is pretty split up in that sense. So it could probably be separated out in the sense of, you know, the first step that we do is we detect the edges of the phone on the server, and we try to identify that there is a surrounding box. So that could be, I guess, chunked out into something, and then the model being generated, or sorry, the response being generated from the image coming in, that could be chunked out into another one. But then as far as the next step goes, it's the client's, or whatever client takes in this response, it's kind of on that end at that point, so.
Yeah, right here, and then we'll get you back there.
What kind of computer vision stuff do you do on the front end of the neural net? You were talking about edge detection, right? So you're
okay. I let Chris do it because you're the one that ended up figuring this out.
Well, I mean, like,
sorry.
You're not just feeding a bitmap into a massive neural net and getting it to recognize a square or something like that. You're actually doing some sort of computer vision work at the beginning and finding lines or something like that?
So I guess, so we're using like YOLO as the model. So it's based on like a convolutional neural network. So basically what that is it has, it does take in the full image and whatever format we send it to it. And then like basically it has different layers of convolutional operations, which I guess neural nets are more or less a black box. So in theory, through supervised training, sort of the parameters of the network automatically learn in the early layers to detect edges, and then in the next layers, combinations, maybe a corner, and then the next layer, maybe like something higher level than that. So while we say we're doing edge detection and stuff like that, that's sort of the model by doing supervised learning with all of our sort of like blood, sweat, and tears training data. It does learn to do all those sort of feature detection and feature sort of mapping from input to output automatically.
Did you think about using computer vision stuff as a front end for the thing? So you.
So actually, so we do actually, I think we do some pre-processing before. You're on top of that? Yeah.
So on the V2 version, we ended up, it was pretty basic what we were doing. There is some stuff as well, we did some tweaks on the V1 where there were some edges that we wanted to detect. So it was just some basic stuff that we found online. It was just using canny edge detection and then using a Huffline transform to try to really find the edges, and then we used that as the bounding box for the actual phone. And then all of the elements inside were detected with YOLO. And then as far as it goes after that, it was the placement, and that's what Chris did as well, where it was really hard to find out the placement of everything inside. As far as the client side goes, from my understanding, I think we were doing like Otsu's thresholding to like, we're trying to put everything into binary, so just pure black and white. And it was just playing around with a bunch of different thresholds and seeing how we can make the model perform a little bit better. Because from my understanding as well, we did make everything black and white before we put it into Recreate as well, right?
No, we just ended up like playing with like the image distortion and like the color channels a little bit.
Oh.
So it was still like candidates for real photographs that you could have taken. But for the trade, we got it.
So did you correct for images that weren't aligned with the camera and so on?
So
Or-
I think our solutions were meant to be very robust to that kind of thing, that how it takes photos. So we actually, when we trained it for both versions, applied like automatic distortions to it and stuff. So we like performed flips of things and stuff like that. Things that would be realistic, and same with skews, like being a little too zoomed in, things like that. Because if we train the network end to end on this synthetic data that does have these imperfections, the network becomes more robust to handle that as well. So that was one of our big things. Because if we just had trained it and it's perfectly upright every time, then the second someone takes a photo and slightly rotated, suddenly the edges it's looking for is different, and it wouldn't be robust enough to handle that. So for both stages, we do like those forms of data augmentation, and it also helps us create more data. And then back there.
So you mentioned your code is not open source, but you're giving us a URL to look up. So what's on that URL?
So
Very
this-
tentative.
Yeah,
Good.
it's really great. So the TD Lab, which is the R&D lab position at Communitech, they have an organization on GitHub right now. So what we are hoping is that they'll be open sourcing it soon. But this would be the link if it is going to be open source, where you would find it. Yeah, so you can go onto this organization and go ahead and follow it and be subscribed to anything. I know you're shaking your head. Sorry? Yeah, so there's no.
It's gonna be the first.
It'll be the first. There's two projects. One is the back end, and then the other one is the iOS full project. So those are the two that you guys can look out for.
Sorry for asking a second question.
No worries.
Do you know if that code will compile? It's Swift code, right?
Yeah.
So will it compile on Linux?
It's a heavy hitter
Oh.
question.
Only ever tried on Mac OS. So
Please let us know though.
You can submit a bug or put an issue in, I guess. But I would not be able to tell you.
There is another question.
Oh, yeah.
Oh, sorry. Yeah, so you guys said something really interesting. You said that normally your projects are, you try to get something presentable in 2 weeks, and then we move on to something else. So I'm curious about, like, was there any resistance to you guys working on this longer? And did you have ever to fight to convince people to...
I think everybody fought for us to extend it, actually.
I think we were the resistance. We didn't want to do it anymore.
Yeah, it was interesting because at first when we were starting to do it, I don't think, so Dexter and
I think
Chris,
we did have to sell it at
yeah.
first, yeah.
I even think at some points they lost faith, and then when it started doing well, then they thought, oh, okay, I guess this is actually working, and then they kept going with it, and they really started picking it up, and then as soon as we showed the results to the different aspects, or the different teams in the company, they just started saying, hey, this is really great, let's start showing this, let's keep working on it a little bit more, and let's see where it goes. So
I think the bigger battle I think the bigger battle was doing something that was meant for internal and trying to pitch why it would provide value and why like someone like a bank should invest resources into a tool for rapid prototyping and design, because that itself is very out of the domain when we were normally a customer experience lab, like we focused on external like people that bank with TVs. So I think that when we were first just discussing the idea, because maybe it's because we had done everything in the banking domain as a project before, we needed something new. But it was really hard to try and sell on like, what if we could make tools that internally we could make accessible and would actually help basically like the problems we have in design sprints, other teams have as well, and try to make it something more company-wide, which at TD at least, it's 85,000 employees. A lot of them are tellers, but it wasn't, eventually we were able to sell it and stuff, but I can see at smaller organizations, you would get a lot more pushback, like to invest 8 months and like, I don't know how many people touched it, like 6 or 7, like over that time period. It's a lot harder of a sell. So I think initially that was the resistance, but then everyone eventually loved how flashy it was after the prototypes, and that's when they wanted it to be like actually built. Yeah.
Did you do any complexity analysis on reliability algorithms?
Define, like, what do you mean by
So,
complexity
like,
analysis?
When you're doing like AI search in images, you can do DFS, you can do DFS, you can do different algorithms to like recognize different modules and different parts of the design. We can break it. We can like use different charts and different ways to manage both memory and the amount of CPU, and how you can async it so that it doesn't like completely take over, and you can slowly try to render it. So there are different like strategies that you can take and like kind of improve the performance. So you mentioned how like you were improving performance to 1.5 seconds. And so I'm assuming that you did some analysis on your algorithms.
So that was really from taking it from just going server side to client side, and then going from a normal YOLO model to a tiny YOLO model because it had a lot less weights that it was performing on. We didn't play with a lot of alternate algorithms, again, because of time. Keep using that as an excuse. Do you have something to add?
I mean, really it was, we didn't go a lot into more of the theory of like what's the complexity order, whatever of it, because the bottlenecks were just elsewhere. Like Dexter talked about, we wanted to kind of like, when it got passed on, sort of hit the biggest problem area, and then we saw it, or they saw it, like a 10x improvement in speed. So I think if we were to continue to work on it, maybe we get another 10x by doing more sort of optimizations of the algorithms themselves, but we're trying to allocate resources to the most impactful sort of areas of the project.
I think you had a question.
So if I understand correctly, the objective of your project was to identify UI elements on a mobile display.
Yeah.
So what would be some of the use for this? I mean, is it like you want to automate human interaction with the thing that if it identifies a button, then it clicks, or if it's a drop down, it chooses something?
So it really was just to speed up the flow of going from a hand-drawn mock-up to seeing what it would look like as an app without having to build it out.
Okay, so
yeah.
create it. So if you have a hand-drawn model.
Yeah, the hand-drawn to create a mock-up of it, basically. Nothing that would be usable code for anything, but we thought the biggest step is like we would draw all of these different mock-ups, but then you have to code them out or you have to design them in some software, and then if you decide you want to scrap them, you've wasted a lot of time doing that flow. So we could just automate and speed up that first little transition going from the hand-drawn mock-up just to see what it looks like, so then you can start to see like, hey, this is kind of the layout I want, then you can actually design it. It really was for that part of the flow. I think besides rendering it as an app, extending it, we would have really liked to have been able to export it as some sort of like, for Adobe, I don't know what the Adobe like software is for designs, but like either Sketch or some sort of like actual design software, so then designers could also like have their process set up.
So one nice thing as well was, since they were actual UI elements built on an iOS, so all the UI rects, or like the rectangles, we had full frames for everything actually being built. And so theoretically speaking, the next step that we could have taken was to export it into Swift files that could be used as like a programmatic UI builder. So it's definitely possible, but that would be another quite large milestone to achieve from where we were.
Oh, one more here. Sorry, we're really keeping you guys with the questions.
So you've sort of got the meat of the machine learning model, and then the bun that's wrapping around that. What would you say is the ratio of time or effort or bugs between those?
It's harder when every part of the project was so buggy, but
I mean, so in some aspects it worked very, very well, completely bug-free. As long as you followed some of our guidelines, you could potentially build up full working screens. I know Jacob worked really, really hard as well on the element inspector, so even when you had it built out, and if something was drawn slightly incorrectly or whatever, the element inspector was able to change colors, text, corner radius. We were even thinking about adding an option to make it so that you could hold press to move the elements as well, and then also introduce snapping. But generally speaking, it worked pretty well. There were only a few edge cases that really broke everything.
So not just in terms of bugs, but in terms of like the time and the effort that your team spent on it.
Oh, I don't think we really spent too much time on bugs.
No, just in general though, like machine learning versus
yeah.
I'd say like the label collection or data collection, that wasted a lot of time. Like having people, we're lucky we had so many interns in this place to just like draw them. But then Chris and I were the ones labeling them after, and that like right off the bat, before we could even prototype, we had spent like over a week doing that.
Yeah, I mean, the actual sexy part of machine learning, which is like having a model, training it, like even for me, and I was the one sort of tasked to do that, maybe 20-30% of the time that I put on the project. I'd say maybe the other 40% was, or maybe 30% the collection and annotation, and then the last, actually probably largest chunk was developing the algorithm that took the output of the machine learning model and sort of transformed it into a JSON structure that could be read by the developers. So it's kind of
200% of your time on that.
Yes, yes.
So you mentioned that you had a library that was a lot faster in processing video as well. Did you ever think about recording people drawing and like recognizing what they were drawing as they were drawing it?
I never thought of that.
That's a good one.
Yeah, that's really interesting. I know there's, I forget what it's called, Quick Sketch. I think it's a project that Google had where they have a data set. So it's basically they had people hand draw different, like a happy face or a house or a fish. And they released a data set, one of them actually being the images themselves in just whatever format, but the other one being sort of like, I don't know what format it was in, but it was like the vectors of their actual like drawing and sort of over time how that changed. So we never really went there because like the idea was you hand draw it on a piece of paper, and to like record someone on a piece of paper, it just adds a lot more complexity there. But sort of that domain of like if it was, you know, you actually touch and you draw on the screen with your finger, then perhaps we could, you know, automatically say you've done 50% of a button. We think it's a button and it pops a button there. That's like maybe version 5 or 7 or something. But it's like definitely it's a different type of project. It's like a time series versus just a image based. But yeah, good idea for whoever ends up working on it in 3 years.
Yeah.
Just a quick, so it's 8:40 right now. So if you don't want to ask questions, feel free to head home.
I think we'll end the big Q&A, but feel free to approach us.
Feel free to come talk to us, ask questions, whatever you guys want. But I just don't want to keep anybody from going home to their wife and children,
Dan?
husband. Oh, so for TD's sake as well.
They have a camera.
For camera, if everybody could, if you could,
overlords.
Yeah, if you could raise your hands if you would like to see this project go open source, please raise your hand. Please, everybody raise your hands.
Just raise your hand.
Do you hear that, TD?
Is it photo or video? Video.
All right, thanks, guys. Thank you very much. And thank you for our co-ops for coming up to Improv 2
Our
and
panel.
Our panel.